Welcome, everyone. Today, we are diving into a critical aspect of AI governance in Snowflake, managing the specific privileges and roles required to securely run Snowflake Cortex Large Language Model, or LLM, functions. Let's get started. Let's begin with the what. When we talk about required privileges for LLM functions in Snowflake, we're referring to the specific access controls that allow a user to run Cortex AI features. At the most basic level, a user must have the Use AI functions account level privilege. But having that isn't quite enough. They also need a specific database role, primarily the Snowflake.Cortex user role. Why is this so crucial? Well, LLMs consume tokens, and tokens translate to compute costs. If you don't control who can run these functions, you can't control your AI spending or your data governance. This is your first line of defense. Looking at this flowchart, you can see the journey of authorization. The user session relies on an account role. For that role to reach Snowflake Cortex LLMs, it must pass through two gateways simultaneously. It needs the Use AI functions account level privilege, and it needs the Cortex user database role. Both are mandatory to unlock the AI capabilities. Now let's talk about the default state of these privileges. Out of the box, Snowflake makes it incredibly easy to start experimenting. Both the Use AI functions privilege and the Cortex user database role are automatically granted to the public role. Since every user in Snowflake inherits the public role, this effectively means everyone in your account can start prompting LLMs immediately. Why did Snowflake do this? To remove friction for developers and analysts. But here is the catch: what's great for exploration is rarely good for production. Leaving these powerful, compute-consuming functions available to everyone poses significant governance and financial risks. We need to lock this down. This diagram illustrates the default, out-of-the-box architecture. Notice how the public role sits at the top, automatically inheriting both the Use AI functions privilege and the Cortex user role. Because every user flows out of the public role, every single user gets immediate, unrestricted access to the AI tools. So, how do we secure our environment? It's a straightforward process, but you must be an account admin to do it. First, you explicitly revoke the Use AI functions privilege from the public role. Second, you revoke the Cortex user database role from public. Instantly, you've stopped unauthorized access. But your approved data scientists still need to work. That brings us to step 3. You create a dedicated custom role, perhaps called Cortex user role. Finally, you grant the necessary AI privileges exclusively to this custom role, and then assign that role only to the specific users who are authorized and trained to use LLMs. Here we see the sequence of commands an admin performs. The admin first strips the privileges away from the public role. Then, the admin channels those exact same privileges into a tightly controlled custom role. Finally, the admin grants this custom role only to the approved user, establishing a secure perimeter around our AI functions. Let's take a deep dive into the ecosystem of Cortex database roles. It's not just a one-size-fits-all situation. We already met Cortex user, which is the master key for all AI features. But what if an analyst only needs to run simple sentiment analysis and shouldn't be spinning up expensive Cortex agents? For that, Snowflake provides the AI functions user role. It permits scalar functions, but blocks the heavier agentic services. Additionally, there is the Cortex embed user role. This is tailor-made for engineers who just need to generate vector embeddings for RAG applications. By dividing these capabilities, Snowflake allows you to enforce the principle of least privilege flawlessly. This chart conceptually visualizes how the privileges are divided. The Cortex user represents the full pie of capabilities. However, you can slice off specific functionality like scalar functions with AI functions user or vector operations with Cortex embed UCR and hand those smaller slices to users who don't need administrative-level AI access. Let's push further into advanced governance. What if you want your users to run LLMs, but you only want them using smaller, cost-effective models like Llama 3.8b, while blocking massive models like Claude 3.5 Sonnet? You can do this via model-level RBC. First, you can set an account-wide parameter called Cortex Models Allow List to broadly filter available models. Better yet, you can run a system procedure called Cortex Base Models Refresh. This generates specific application roles for every single model in the Snowflake.model schema. You can then selectively grant access to a specific model role. This means you control not just if someone can use AI, but which exact brain they are allowed to query. In this flow, the administrator refreshes the models, which populates the Snowflake.model schema. From there, distinct roles are created for each LLM. Notice how we route the lightweight Llama model to the junior analyst, while reserving the highly capable, but more expensive, Claude model for the senior data scientist. Let's look at execution contexts, specifically when you embed Cortex AI inside stored procedures or Snowpark container services. If you design a procedure that runs with execute AS restricted caller, you are intentionally limiting the caller's permissions for security. But for Cortex to work in this lockdown state, you have to be precise with your grants. You must grant the use AI functions privilege to both the role executing the session and the role that owns the service. Furthermore, you have to explicitly grant inherited caller usage on the Snowflake database schemas. If you miss these steps, your automated AI pipelines will fail with authorization errors. This state diagram shows the dependencies for a restricted caller stored procedure. Once the procedure enters the restricted state, it forks its permission checks. It verifies that the session role has AI privileges, and it simultaneously checks that the application owner role has AI privileges. Only when both clear do we achieve execution success. Let's ground this in a real-world use case. Imagine you are managing a massive customer support pipeline. You want to automatically run the AI sentiment function on millions of incoming tickets to flag angry customers. However, you absolutely do not want the application handling these tickets to have the ability to spin up Cortex Search services or engage in open-ended chat, which could skyrocket your compute bill. The solution, you create a custom support app role and grant it the AI functions user database role. This acts as a surgical strike. The app gets exactly what it needs: scalar AI functions for sentiment analysis while remaining securely fenced off from the broader AI features. Follow the data flow here. The support tickets feed into an application role. Because that role is granted AI functions user, it is allowed to route data into the AI sentiment function, feeding our dashboard. However, notice the dotted line: the role explicitly blocks access to Cortex agents, ensuring cost and security control. To wrap up, remember that while Snowflake makes Gen AI highly accessible, applying strict role-based access control is your responsibility. Always revoke those default public grants in your production environments. Use granular roles like AI functions user and leverage model-level RBC to maintain strict cost control. And don't forget to monitor your success. You can track exactly who is spending what by querying the Cortex functions usage history view. Thank you for joining me for this deep dive. If you found this valuable, please invite your peers to like and subscribe. And be sure to visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. See you in the next lesson. This final cycle represents your ongoing AI governance loop. You implement your roles, assign specific privileges, and execute your AI workloads safely. Crucially, you then monitor that usage history, using those insights to continuously optimize and secure your environment.